Welcome to tonight's video on Unit 10, Part 3. We're going to be talking about continuity and then how that relates to the intermediate value theorem. So just to review what it means for a function to be continuous at a certain point, and that is when the three conditions are met, that the limit as f approaches that number exists, that f of c is defined, and that the limit of the function at that number and f of c are the same. Doesn't matter what order those first two occur, just that they happen. And if one of those two is not true, then it is not continuous. In order to be continuous on an open interval, that means it would be continuous for the entire real number line, whereas on a closed interval would be continuous between two numbers. So to figure out if a function is continuous at a certain value, for example, here at c equals 1, first we have to find the limit as x approaches 1, which means we can directly substitute in. And we get 3. F of 1, when you put in 1, is also 3. So therefore, since the limit as x approaches 1 of the function is equal to f of 1, the function is continuous at 1. So if we try the next one is an absolute value, so it's a piecewise function. So we're going to have to define the piecewise function. It's x squared minus 3x plus 2 if what's inside is greater than or equal to 0. And it's the opposite if x squared minus 3x plus 2 is less than 0. Well, let's think about this inequality for a second. X squared minus 3x plus 2 is greater than or equal to 0. Well, that means if you factor, the critical numbers are 2 and 1. And then remember, you can test. So if you put in 0, that means negative and negative is a positive. If you put in 1.5, you get negative and positive, which is negative, and 3 would be positive. So that means it's greater than or equal to 0 if it's less than 1 or greater than 2. So if we rewrite this function, x is less than or equal to 1 or greater than or equal to 2, and it's the opposite if x is between 1 and 2. So now, to find f of c, well, f of 1 here, well, when it equals 1, we get 1 squared minus 3 times 1 plus 2. So it's equal to 1 minus negative 2 plus 2, which is 0. Now the limit as x approaches 1 from the left, because now it's a piecewise function, so we have to go left and right. So from the left is when it's less than 1. So therefore, from the left here would be 0. And from the right, when it's greater than 1, which means this one here, well, if you put 1 in here, you get negative 1 plus 3, which is negative 2, which is negative 2 plus, or sorry, minus 2, which is negative 4. So the limit from the right is actually negative 4. So therefore, the limit as x approaches 1 of this function here does not exist, because the limit from the left does not equal the limit from the right. Therefore, f of x is not continuous. Or in this case, sorry, not f of x, but it's m of x. Sorry, the m of x is not continuous at 1. All right, so let's look at a couple more. For this one, number 3, if you look here at 2, well, first all we have to do is see g of 2, and notice that it can't equal 2. So g of 2 is undefined. And since g of 2 is undefined, g of x is not continuous at 2. And last but not least, on this one, another piecewise function. Well, first h of 2, well, if we put in 2 here, we get 3 times 2 squared plus 2 plus 1. So we get 4 times 3 is 12, plus 2 is 14, 15. So h of 2 is 15. Now the limit as x approaches 2 of h of x, well, 2 is not a boundary turning point, so we can directly substitute it in to the top. And so we get 3 times 2 squared plus 2 plus 1. So we also get 15. So notice, since the limit and the value of the function are the same, of h of x, and equals h of 2, h of x is continuous at 2. So the next question is, how does the being continuous or continuity affect the intermediate value theorem? And basically the intermediate value theorem says if the function is continuous function on a closed interval, all right, and f of a does not equal f of b, and k is any number between f of a and f of b, then there exists at least one number c such that f of c will equal k. So we'll figure that out. We'll kind of give an example here. So it says let f be continuous on the interval 1 to 4, where f of 1 is 7 and f of 4 is -1. So if you draw the picture, so f of 1 is 7. Right there. F of 4 is -1 right here. Draw a sketch based on the given information. Okay, so we'll just make a sketch like that. All right, so choose an appropriate value for k. So k has to be between 7 and -1. So for example, let's let k be 1 right here. So this is k. K equals 1. All right, so if k equals 1, notice c here, the c value for k, right there, the x value, c is equal to 3.5. All right, so if you notice, 3.5 is between 1 and 4. And that's what the intermediate value says. So if it says, if I choose any k between -1 and 7, any y value between -1 and 7, c will have to be, the x coordinate will have to be between 1 and 4. If the function is continuous between 1 and 4. And that's what it said. Now, if the function were not continuous on the interval between 1 and 4, would there necessarily exist a value for c? Would there necessarily exist a value for c if the function were not continuous? So, for example, if I drew, like, so f of 1 is 7. So there's 7. F of 4 is -1. But let's say if I had the function like this and like that. So notice there's a k value here at 4 that is not continuous. I mean, that is not, that there's no value for. So for the indicated value k here, there is no corresponding c values. Right, so if the function's not continuous, then it doesn't work. Then it's not necessarily true. But if the function is continuous, then you know you're guaranteed to have a value between 1 and 4 that will give you that value of k that is between the y coordinates of 1 and 4. So here's another example. So if we look at this function and we want to determine, does the intermediate value theorem apply, where c is between 1 and 5, and 1 and 5 are the x values, such that f of c is 12, given that f of x equals x squared plus 4x minus 20. If so, find c. So the first step, is the function continuous on the interval of 1 to 5? And the answer is yes. Why? Because f of x is a polynomial, and all polynomial functions are continuous. So since it's a polynomial, we know that it is continuous on the interval from 1 to 5. So that's step 1. We know it's continuous from 1 to 5. Step 2, find f of 1 and f of 5. So f of 1, when we substitute it in, so we get 1 plus 5 minus 20 is -15. F of 5, so it's 5 squared plus 4 times 5 minus 20. So it's going to give you 25. So are they equal? No, f of 1 is not equal to f of 5. So therefore, and you notice 12 is the value of k, and that is between -15 and 25. That's something to notice. So now for step 3, what is the value of k? K is 12. That was told us. F of c is 12. And is k between f of a and f of b? And that is true. So then for step 4, does the intermediate value theorem apply? And the answer is yes, since f of 1 is between, since 12 is between f of 1 and f of 5, the intermediate value theorem, you can abbreviate IVT, guarantees that C will exist between 1 and 5. All right, so it guarantees that C will exist, and that's what that E means. C exists between 1 and 5. Such that, and you can abbreviate ST if you want, such that f of C is equal to 12. So number 5 says find what the value of C has to be. So you know that C squared plus 4C minus 20 is equal to 12, because that's what f of C is equal to. So you got to solve this. So you subtract 12, so you get C squared plus 4C minus 32 equals 0. You factor C plus 8, C minus 4 equals 0. So you get C equals negative 8 and C equals 4. Now remember, C has to be between 1 and 5, so negative 8 does not work. So therefore C is equal to 4, because that's the one that's between 1 and 5. All right, let's try the next one. So verify here that the intermediate value theorem applies and find a C that's between 0 and 2 such that f of C is 0, and given that f of x is x squared plus 2x minus 3. Well, the first thing we know is f is continuous because it's a polynomial on the interval of 0 to 2. Since it's a polynomial, we know that. Step 2, find f of 0. Well, f of 0, 0 squared plus 0 minus 3 is negative 3. And f of 2, when you substitute it in, you get 2 squared plus 2 times 2 minus 3. So 4 plus 4, 8 minus 3 is 5. All right, so does the intermediate value theorem apply? Because we know f of 0 does not equal f of 2. And the answer to that question is yes, because k is equal to 0 and negative 3 is less than 0, which is less than 5. So basically that k value is between negative 3 and 5. So since it's between negative 3 and 5, and we'll say that in step 4, since k is between f of 0 and f of 2, the intermediate value theorem guarantees that C will exist between 0 and 2 such that f of C will equal 0. So now we just have to find what C is, and that means that we go C squared plus 2C minus 3 equals 0. So we factor C plus 3, C minus 1. So C equals negative 3 or C equals 1. And remember, it has to be between 0 and 2. So it can't equal negative 3. It has to only equal 1. So last one. If you want, you can pause the video and try it on your own. We know f of x here is continuous because it's a polynomial. We know that f of negative 2 equals negative 8 plus negative 4 plus 5, so it equals negative it equals negative 7, and then f of 0 is equal to 5. So we know that f of negative 2 does not equal f of 0, and since k equals 0, because that's what it means to have a 0, is that the c is going to, f of c is going to equal 0. And we know negative 11, we know 0 is between negative 7, sorry, not negative 11, negative 7 and 5. So therefore, since f of negative 2 is less than 0, which is less than f of 0, or another way to say it is 0 is between f of negative 2 and f of 0, the intermediate value theorem guarantees that c exists between 0 and 2 such that f of c is equal to 0. And the problem doesn't ask us to find the 0, so we don't have to find the 0. In this case, it doesn't say find c. It just means to verify that it has a 0. So therefore, we can stop there. All right, hopefully the intermediate value makes sense to you, and if not, please feel free to ask questions, and I hope you have a good rest of your evening.